Hey everybody, welcome back. This is Middle School Math with Dr. K, and today we're going to talk about how to graph an inequality on a number line. Let's jump right in. So I've got a bunch of examples I want to work through. This should be a really speedy, quick video because graphing on a number line is relatively easy. So when you have an inequality, it's a little bit different than a solution to an equation in that there are lots of solutions. This says, for example, that x is greater than 2. Well, I bet you could think of some numbers that are greater than 2, like 3 and 4 and 7 and 15 and 1,000 and 1,520,678. There are lots of numbers greater than 2. So with an inequality, we often will show all of the numbers greater than 2 on a number line. To do so, we want the number that we're working with, the 2, in the middle, and I usually put 2 numbers to the left and 2 numbers to the right. Remember that when you learned about number lines in the first place, the smaller numbers go on the left, the bigger numbers go on the right. Now, because we want things greater than 2, I'm going to circle my 2 because that gives me a starting point, and I'm going to point an arrow towards the greater numbers, or towards the right. That's it. That's graphing an inequality. Let's take a look at another example. Example 2 says that I want numbers that are less than or equal to -5. So things that are less than -5 might be -100, they might be -62, they might be -7. But this one also has this little equal symbol right here. It's this underline. So that means I can also include -5, but I can't go any further than that. So to graph it on a number line, I need -5. Again, I need 2 numbers that are bigger and 2 numbers that are smaller. Now, when you're working with negatives, be very careful that you actually get numbers that are bigger and smaller. So the bigger numbers move towards 0, they're on the right side, and the smaller numbers move toward like -100, and those are going to be on the left side. So this time I'm looking for numbers that are less than or equal to -5. So I'll still circle my -5, but I'm going to fill it in. And the reason I do that is because of that equal to piece. This time, -5 is a solution to the inequality, which means I can fill in that circle and I can show that I want everything that is less than -5. Example 3 is very much the same idea. So I want numbers that are less than -6.5. So I'll start by putting -6.5. Remember, on the right side, we're getting larger numbers, so we're moving closer to 0. You could do it a number of different ways. You might do -6.4 and -6.3. You could even count by wholes, so that would make it -5.5 and -4.5. However you do it, it's important that you're counting really consistently. So if I count by one whole in one space, I have to count by one whole for every space. Now I'm looking for W to represent numbers that are less than -6.5, but not equal to. So like the first example where I wanted greater than, this time I want less than, but I'm not equal to, so I'm still going to have just a circle around the 6.5 as a starting point, and I'm going to show that I want all the less than numbers, so my arrow will go to the left. Here are a few more examples looking at different situations you might see with inequalities, but what it really comes down to is, do you want less than numbers or greater than numbers? And are you including that value, like is there an equal to portion or is there not? And those are kind of the two factors to graphing an inequality. It's pretty straightforward. So here I have -3/4, -3/4. And when I'm counting by a fraction, I actually count by the numerator usually. So that would be -2/4 and then -1/4, -4/4, and -5/4. What's important to me is that we then go back and check to see if we need to simplify fractions. In this case, I do have 2 fractions that will simplify. -4/4 is the same as -1, and -2/4 is the same as -1/2. Now we've got the most accurate, most complete number line because we not only counted consistently, but then went back and simplified anything that needed to be simplified. So looking at the inequality I'm graphing, I want P to represent numbers that are greater than or equal to, just like on example 2, -3/4. So I'll circle my -3/4, and because I'm looking for values that are greater, I'll move to the right. And because it also says equal to, I'll fill in my circle. So hopefully you're noticing a pattern. If you've got this equal to sign, your circle is going to be filled in. Otherwise, it's not. Example 5 is interesting because sometimes you see an inequality that's kind of flipped around. So you really have to think about, is G representing bigger numbers or smaller numbers? In this case, G is representing smaller numbers. So some people like to think of this as an alligator mouth, or gosh, I've heard so many variations. Alligator mouth or a monster mouth, and it always wants to eat the larger thing. So, or like a Pac-Man. If the Pac-Man is eating the -12, that means G is smaller. It's not as big as -12. So when I graph, I need to represent that. -12, remember the larger numbers move you closer to 0. I'm going to go ahead and circle my -12, and you should be thinking at this point, do I fill in that circle or do I not? Well, there's not an equal to sign, so this time it's not filled in. Now, we said that since the alligator mouth is eating the -12, that means that G represents numbers that are less than -12, so I want my arrow to point to the left. Now, some people find it really helpful to rewrite an inequality if the letter is not placed first. You can do that, but some things you should be careful about are if you're going to move things around, you really have to be cautious about how you do it. For example, I can switch the G and I can switch the -12. But if the alligator mouth was eating the -12, it still needs to be eating the -12. So you'll notice that the whole thing flips. The G and -12 flip places, and the symbol flips as well. Now with inequalities, that's really important so that the larger thing stays larger if you rewrite it. If you didn't flip the sign, you'd actually be changing the value of this inequality, and that would be a problem. Now, if you do that, the sign can actually be kind of a hint towards an arrow pointing to the left. So you can use that as kind of a hint for should my arrow on my graph go left or right, but only if your variable is first. So let's look at one more example of that. On example 6, I have -14.5 is greater than or equal to h. So if I wanted to rewrite this to put my variable first, I can flip around the h and the -14.5. I see that the alligator mouth was eating the -14.5, so I need it to still be eating the -14.5, which means it flips directions. So again, be really careful. If you're going to move things around, make sure you flip everything. So the h and the -14.5 switched places, and my sign flipped too. Now, like I was saying before, you think of this as a hint that your arrow should be pointing to the left. Some people like thinking of that in that way. It's nice because it is a less than symbol, and less than means we're typically pointing to the left because our variable is representing things that are less than -14.5, and our lesser numbers are on the left. So let's go ahead and do that. You can do a number of different counting ways. I prefer to go by ones. It just seems easiest to me, but you can count by decimals as long as whatever you do it really consistently. On a number line, we really want to count by the exact same thing every time. We don't want to be skipping numbers and counting by 2 here and 4 there and 5 there. I will go ahead and circle my -14.5. That's my starting point. I see that my inequality does have the equal sign on it, so I'll fill that in as well. And then again, since I want numbers that are less than -14.5, my arrow goes to the left. So these are a few hints for what you need to remember. Inequalities, unlike equations, have lots of solutions. That's why we graph them. So we graph them on a number line, and we add an arrow to show that there are many, in fact, an infinite number of things that are less than 12, or an infinite number of things that are greater than or equal to -5. So we use a graph to show that there are infinite solutions. It's also helpful sometimes to rewrite the answer to make sure that the letter comes first, like we did on examples 5 and 6. But if you have to flip an inequality around, make sure to flip everything. So swap the letter and the number and flip the sign. Some other things to remember are that if you have an equal to piece, you have a filled in circle. You need to shade it in. If you don't have an equal to, if it's just less than or greater, then you're going to see an empty circle on your number line saying that that number isn't exactly included. It's just a starting point. So I hope this gives you some idea of how to graph inequalities. Go graph, have a great time, and I'll see you next time.